Picture this, a tool so finely tuned, it's like having a magnifying glass for quality control. Think of the attribute control chart as your trusted guide through the labyrinth of quality management. But here's the beauty of it, it's not just about keeping tabs on what's already there. It's about spotting potential hiccups before they become headaches. The attribute control chart acts as your early warning system, alerting you to any deviations from the norm so you can step in and set things straight. Let's open Power BI and have a closer look at the attribute control chart. Here we have all 6 charts, all available within the attribute control chart. The U chart that tracks the number of defects per unit when the sample size varies. The C chart that monitors the number of defects in each sample when the sample size is constant. The P chart that observes the proportion of defective items in each sample when the sample size varies. And the NP chart that displays the count of defective items in each sample when the sample size is constant. When you have large sample sizes, you could face over or under dispersion. Then you probably need one of the following Laney charts. The Laney U chart. This is a modified version of the U chart. And the Laney P chart, which is a modified version of the P chart. All these charts support the same features, they just apply a slightly different calculation to determine the control limits. Let's have a closer look at some of the features of the attribute control chart. The first important feature is the automatic calculation of all the derived series and potential signals. The visual will calculate the central line and both the upper and lower control limit. It will also highlight any signal, like we see here in period 6. You can change the signal detection in 2 different ways, as a report developer, but also as the report consumer. Let's edit this report to see the options of the report developer. We open the formatting pane and go to the calculations section. Here we can change the behavior of the signal detection. Let's change rule 2. This rule is endpoints in a row on the same side of the central line. By default it is on 9, but if we change this to 5, you'll see the signal appear in the chart. Let's also change rule 3. This rule is endpoints in a row are continually increasing or decreasing. Let's change this to 4 and we'll see 2 new signals appear in the chart. In general, we'll keep these rules on their standard values, but if needed, you can change them here. Let's return to the default setting and have a look at the features the report consumers have. Let's open the focus mode of the visual so we can change the rule settings when consuming the report with the attribute control chart. In focus mode, we see the control chart on the left and the rule statistics on the right. The rule statistics contain all the signals and the derived figures used in the calculation. When we select the calculator, we can temporarily change the rule settings. Let's change some of the rule thresholds here to see some additional signals in our control chart. We can even decide to switch some rules on or off. Once we have the result we are looking for, we can download these statistics to a CSV file. When you exit the focus mode, all rule settings return to the original settings as set by the report developer. Download your copy of the attribute control chart now and start detecting potential deviations. It's time to step in and set things straight.